Hello and welcome to the Narda Safety Test Solutions YouTube channel. This time we are going to take a look at the principles and measurement of 5G signals. So, what is 5G and how is it measured correctly? This video is in 4 parts. Part 1 gives you an overview of the various mobile communication systems, starting with GSM. Part 2 explains the terminology like TDD or beamforming. Part 3 looks at the effect of 5G on electromagnetic field measurement devices and considers the different measurement situation. Finally, Part 4 examines the question of why extrapolation is also appropriate for 5G and what the current status is with regards to a measurement recommendation. Let's start with an overview of 5G and the system that preceded it. 5G, or 5G New Radio as some like to call it, is a mobile communication standard for the years ahead. To some extent, 5G New Radio and the associated technologies and frequencies set new challenges for the measurement equipment when it comes to human safety in electromagnetic fields. Along with 5G, beamforming and massive MIMO are also being rolled out for mobile communications. First of all, let's take a quick look back at the previous mobile phone systems and compare them with 5G. The overview shows that, as well as the frequencies, their bandwidths have also increased with each successive generation of mobile communications. Bandwidths up to 400 MHz have in the meantime become necessary in order to satisfy the digital world's appetite for data. Such bandwidths are simply unavailable within the frequency bands of conventional mobile phone systems. As a result, a move towards higher frequencies is inevitable. In return, previously undreamt of data rates can be achieved. In this way, 5G will not only be a new standard in mobile communication, it is capable of replacing many of older services and of finding application in many areas where mobile phones have not played a part so far. In this context, we only have to think of application in the industrial sector, the Internet of Things, or car-to-car communication. The thing that makes 5G so attractive to industry, for example, is a fast reaction time or latency. This enables it to also take over functions in machine control. Right from the start, MIMO antennas have been used in the transmission of mobile communication signals. Exactly what that is will be explained in the next part of the video. The signal structure of 5G is very similar to that of 5G LTE. In the frequency range up to 6 GHz, 5G can occupy channel bandwidth of up to 100 MHz. That's 5 times as much as LTE. What is more, it will for the first time in mobile communications also use frequencies that are considerably higher than 6 GHz. Frequencies of 24 to 30 GHz and bandwidths up to 400 MHz are only the first step, to be followed by further steps towards even higher frequencies. This image shows a comparison of the spectrum of the different mobile communications generations. They have all been recorded with the same frequency span. Only the center frequencies are different. You can still see the individual carrier signals in GSM, but these are so closely packed together in the higher generation that they appear as a compact block in an overview measurement using a spectrum analyzer. The utilization of the frequency band is increasingly efficient. That's the end of part 1. Part 2 will look at the different terminologies and the technologies that are associated with 5G.